Hey, calculus students, this is the video for lesson 6-1. Actually, should be fairly quick one. There's not much in this section. Okay, so it's just exploring accumulation of change. That's what section 6-1 is. So we start out with this example. So well, let's start, it's just an introduction kind of thing. So this is a graph of f prime, the derivative of f is shown to the left. They tell you on the function, you have the coordinate point 0, 0. Remember, this isn't the function, this is f prime. And it tells you at x equals 0 that the derivative is 1. So that means, I wrote it over here, at x equals 0, f is increasing because f prime is positive because it's 1. So if you just kind of, and then this is our choices here, figuring out on the function which is bigger, so not on the graph. The graph is of the derivative. So if f prime is positive on 0, 2, which you can see right here, f prime is positive on 0, 2, that means that f is increasing. So that means that f of 2 is going to be greater than f of 1 is going to be greater than f of 0, okay, because the graph of f is increasing on that whole interval. And then at 2, it starts to decrease. So I said from 2 to 3, it starts to decrease. But there's not enough. It decreases pretty slowly here for f of 1 to be greater than f of 3. So if I look at these choices, f of 0 can't be greater than f of 1 because the graph is increasing. F of 2 can definitely be greater than f of 1 because we know it is positive or increasing at f of 0. But we're also saying at f of 2, it starts to decrease. So it doesn't look like there's enough here to make f of 1 greater than f of 3. So the correct answer here is B. 2 only is the only one that's true. Okay, this next one is definitely just kind of an introduction. And remember, if you want to see other videos on these problems from the teacher who actually wrote these notes, you can scan these QR codes. So it says a particle moves along a straight path with a constant velocity. So that's the constant velocity of 2 feet per second. So your y-axis is feet per second, and your x-axis is just time. What is the total distance that it traveled from time equals 0 to time equals 2? So this is the velocity. This is feet per second. So if you can think at time equals 0, it hasn't moved yet. So the area would be 0, or the distance traveled would be 0. If you look at time equals 1 second, after 1 second, you can see it's traveled 2 feet per second. So the distance it traveled would be 2 feet. So what the total distance is actually what is the area under the curve and above the x-axis. So when it asks for how far did it travel, it's basically asking for the area of that region right there. So how far did it travel? Well, that's a 2 by 2 square. So it traveled 4 feet. This is getting into what we do when we take an antiderivative or we take an integral. Okay, last one is, I'll let you pause and read all this. I kind of highlighted some important stuff. A rate, so you can think about this graph as a derivative because they said it's a rate, the number of downloads per week. How many total downloads were purchased during the 10-week period? Again, that's going to be the area under the curve. This isn't really a curve, but you get the idea. Under the graph and above the x-axis. So we're going to use geometry to find this area because the graph is all straight lines. And if you look for some nice points to calculate your area. If you look here, the graph does a turn at x equals 4. So we can find one area from 0 to 4. We're going to find the area of that rectangle. And then from 4 to 6, that you can either think of it as a trapezoid or a triangle plus a rectangle. So we can find that area. And then the third one would be from 6 to 10. So that would be that. Again, you could do this as a trapezoid, or you could do this triangle plus this rectangle. All right, so the square, or the rectangle is going to be easy. That's a 4 by 3 rectangle. So that area is going to be 12. So this area is 12. 4 to 6, if I do the trapezoid, that would be finding this whole area. And I want to take the average of these two heights. So this height is at 3, this height is at 1. So it would be 1/2 3 plus 1 times the width, which is 2. So that would be 4. So this area would be 4. If you forget your formula for area of a trapezoid, again, you could do this area, find the area of this triangle, which is 1/2 base times height. The base is 2, the height is 2. Half of that would be 2. So area of this triangle would be 2, and area of this rectangle would be 2. And when you add those, you would get 4. The formula for area of a trapezoid is like base 1 plus base 2 over 2 times the height. Or you could think of it in our situation, height 1 plus height 2 divided in half. So the average of the heights times the width of the rectangle. Okay, so the third one is another trapezoid. The first height is 1, the second height is 9, so I'm going to do 1/2 1 plus 9, and the width is 1, 2, 3, 4, and you get 20. So that's the area of the trapezoid. So the downloads purchased were 36, and I think these are thousands. 36,000 downloads. Okay, now what happens when you can't use geometry? This is similar to our example where we had the constant velocity, but now you can see your derivative or your velocity graph is a curve. So to figure out the total distance it traveled, we still want to find the area under this curve, but it's difficult because it's a curve. We can't really use geometry. So this situation is presented in topic 6.2. Really, the rest of the chapter. So antiderivatives, which is what we're starting in chapter 6, is the area under the curve.